right there. So how much aura did I lose exactly? All these videos of people just randomly assigning aura. 1,000,000? 1,000? Let's unscientific boulder dash. That leaves one option: equations. You ask, why are equations so powerful? It's because something simple like this, I can figure out exactly how long it would take to drop to the floor. If you don't trust me, these are roughly my workings to get 0.28 seconds. Check it yourself. This isn't a suvat, this is aura. So we can't measure it, we can't weigh it. What can we do? And so we're going to have to look at some variables, and we're going to need some maths and a scientific process to get to our equation. I can't work all that out on my own, so I'm going to be using the power of clanker slave labour. The key bit is right here. You can see that the 0 to 100, it's just adding an amount of aura, and this shows a potential problem with how if you just add aura and it never decreases, and then we can go back to the graph, then you can see right here that it just continually keeps on increasing. And yeah, that you can't just infinitely farm aura. But this graph still adds quite a lot of area, which is the main measurement of aura. So we have to add this bit under the graph to take away the aura, and then you can do the difference between the red and the green to find out your total aura gain, which will gradually diminish towards 0. This brings us to Desmos, where you can see our graph from Excel, which I did adjust again just to get it more towards what I want it to look like, and you can calculate the total aura with the integral of between 0 and 6.4, because it's only true up until this line, otherwise it does weird stuff. And that allows us to get 2.3, which you can use for calculating the lifetime aura of something happening. Ideally this would peter off, but that was too difficult for me to model at this point. If you did want to calculate just for a moment, you would have to do this integration of the function yourself for, say, up to a minute how much aura was gained, because it may be that you want to calculate more instantaneous aura. I also modelled a second aura graph, which can be seen here, R of X, for something longer term, like receiving an award, which doesn't get you so much in the short term, but loses you less in the long term. Just remember, every time I talk about losing aura, it's about it diminishing back to 0 as people forget, not that getting something will lose you aura overall. Finally, what are the variables that affect aura? First one, pretty obvious. How many people saw you do it? If you're in a classroom, catch a glue stick thrown across the classroom, that's aura extra. Also, how many people would want to be able to do? Well, I would say maybe 90% of people would want to be seen being able to do that. That's another thing that influences aura. And then, finally, what percent of people could do that? Say maybe 40% of people could catch that glue stick. So, let's put them all together to get the holy grail of aura equations. Before I reveal about the aura, we're going to have to like, subscribe, and comment if you think there's something I can do that will help me. Here it is in all its glory. You can see these are what you need if you want to find out she, the symbol here yourself for the function a or r of x. And then here it is, aura equals the number of onlookers times by the number of people who would desire to do it. If people wouldn't want to desire it, this becomes a negative value. How difficult it is to do also is a percentage, p meaning possibility. And by that function, go back to that moment at the start. If we have a look, sub in the value for desire of minus 20%, times by the possibility of that happening. I think probably in day-to-day life, maybe 30%. And then times by our value, short-term aura loss, 2.3. and then times by the number of people watching.